Hello everyone. In this video, let's look at some problems about function transformations. So we have a function here where the original function is f of x equals square root of 1 minus x squared, and that's graphed with the dashed line here in each of these graphs here. So this is the original function. And then we are being given that each column corresponds to one transformation of f of x, which is going to be called g of x. And then we have to fill in the missing entries. So there's 3 rows, verbal description of the transformation, the formula for the transformation of the transformed function, and then the graph. So in the first one here, we see that the red is the new transformed function. And I've given you 3 points here to focus on. Okay, so you want to check what happened to each point. So this point here on the left has gone down to here. The one in the middle has gone to here, and the one on the right is there. Okay, so they each went down by 3. So that is a vertical shift down. Why is it doing that? Hold on a second. Vertical. Oh, okay. Word is messing with my table layout here. Hold on a sec. Okay, so maybe I'm just gonna type these in. I can't deal with this like pen being drawn all over the place. Yeah, so this is vertical shift down by 3 units. Okay. All right. And then what is the formula for that? So for vertical changes, you always make your change to the outside of the formula, to the entire formula as a whole. So the original formula, which we're going to start with, is square root of 1 minus x squared. And we want to shift down by 3. So we're going to, for shifting, you're always going to use plus or minus a number. And since it's vertical, we're doing this to the outside of the formula. Okay, so we are going to subtract 3 from the formula. And now you can always check this by plugging in points. Okay, try plugging in some points. Plug it in these 3 red points down here. Okay, so when you plug in -1, you want to get -3 because that's where the point goes. So let's see, does it work? 1 minus -1 squared minus 3. Okay, what do I get? So inside the square root there, I'm getting 0, I think. Okay, and then I have the -3, so that's just -3. Okay, I got the right answer. Okay, so check, this worked. All right, let's look at the second one. So we're doing a vertical reflection, which means reflection across the x-axis, so top to bottom, flip it upside down. And so we need the formula and we need the sketch. So for the sketch, I should be able to hopefully make Microsoft work for like a second. Okay, so this, everything on the x-axis itself is going to stay where it is. So that point's going to stay there, that point's going to stay there. And this point that's up here at 1 is going to come down below to 1. Okay, so this reflection is going to look like that. All right, and then what is the formula for doing this? So again, let me just start with the original formula, which was, maybe I'll just copy paste this. Okay, and now I'm making a vertical change, so whatever I do is going to go to the outside of the formula. And for reflection, it's just make it negative. So I'm putting a negative on the outside of the formula like that. And again, test a point, okay? So the only point that changed was the one at x equals 0. So if I plug in 0, do I get -1 like I want to get? Let's see. Let me plug into this formula. 1 minus 0 squared. Okay, this is simplifying -1. Yeah, okay, so I got the right value here. So check. All right. So let's look at the third one here. So for this one, I'm given the formula. Well, if you're given the formula, you can just plug in points, right? So even if you don't know what this does, you can plug in points and see what you get. So let me see what happens if I plug in, let's say -1. Okay. Well, actually, let me start with 0 because that's easier. Square root of 0. Okay, 1 minus, this is still going to be 0 squared, right? So that's going to be 1. Okay, so my first point is staying there. If I plug in -1, let's see, 1 minus 1/2 times -1, and then I'm squaring that. Ooh, okay, so what's happening here? It looks like -1/2 squared, so I'm doing 1 minus, what's 1/2 squared? 1/4? Okay, so this is square root of 3/4. So I would need my calculator, but you are going to have one of those. So this is 0.866 approximately. All right. So you could use that information to actually go ahead and plug in some points and then graph it like that. And then from that, you might be able to actually figure out like what was the transformation. So that's one way to handle it. So this would be approximately like right here. And then if you go ahead and do 1, it's going to be right here. Okay. And then if you plug in 2 at -2, I already did these while the video was paused. They go right here and here. So from this, you could actually figure out the graph, and you can probably figure out transformation too, right? Because it's a horizontal stretch by a factor of 2. All right, so let's take that up here. So this is horizontal stretch factor of 2. Now, how could you have actually figured that out from this formula that was given? So you see the only thing that's different is this 1/2 in front of the x. So we've multiplied x by 1/2. Multiplying by a number is for stretching or shrinking. And the fact that it's inside, it's next to the x, not on the outside of the function, that means it's horizontal. So you already know from that it's a horizontal stretch or shrink. And then the only thing to figure out is like, does this make it bigger? Does it make it smaller? Which way? And with the x transformations, the horizontal transformations, they're all backwards. So this looks like it should cut x in half, but what actually happens is that all your x values have to double to give you the same y values as before. So this is actually going to be a stretch by a factor of 2. But if you didn't remember that, you could actually just do this other approach where you plot points. Okay. All right. So that was that problem, and let's go ahead and look at the next one. So the original function is f of x equals 2 plus 1 over x, which is graphed with the dashed line. Okay, it's the last video of the night, and Microsoft Word is making me grouchy. Okay, so that's graphed with the dashed line down here. So that's our original function. And then each column, we're going to do this the same way as before. So in the first one, look at your 3 points that were marked. So this point has gone up to here. This point has gone up to here. This point has gone up to here. Now look, did they all go up by the same amount, or did they go up by a different amount? I think they went up by different amounts. So that tells me this is a stretch, not a shift. So it looks like the y value of this left point went from 1 to 2, the center point went from 2 to 4, and then the third point went from 1 to 2. So it looks like all the y values are doubling. Then that means that this is a vertical stretch by a factor of 2. Okay. And so now how do you write the formula for that? So our formula here, let me start with the original formula, which was this. Okay, so it's a vertical change. So whatever change we do is going to be on the outside of the function to the whole function. And then it's stretching, so we're going to multiply by a number for stretching. And so for the y changes, the vertical changes, they all kind of look the way they're supposed to. If I want to multiply the y values by 2, then I should just literally multiply the formula by 2. So that is what you do. And that way, when you're calculating the formula, you're plugging in x values, you're doing it the same way you did it with the original formula. Then the last step, you're just multiplying all those y values by 2. Okay, so that's this one. Let's look at the next one. So we're shift left by 2. Okay, shift left by 2. So this is not too bad to draw because we're just going to take these 3 points here, the reference points, we're gonna, oops, sorry, I'm already shifting the wrong amount. I'm gonna shift left by 2. So that one goes left by 2, and then this one goes to where this one was, and then we're just kind of connecting them the same way they were connected by before as best as we can. Okay, like that. Now for the formula. How do we do this formula? So I'm going to start with the same formula I had before, and what changes do I need to make? So shift left by 2, it's a horizontal change, so that means whatever we do it to the x, not to the outside of the formula. And it's shifting, so that means we're going to add or subtract a number. Since I'm going to add or subtract a number to this x, I need to get the x in parentheses before I do this to protect it, to protect the order of operations and make sure this happens before it gets squared. Okay, so the only question now is, do I add 2 or do I subtract 2? You can figure this out by plugging in points if you don't remember, but everything is backwards with the horizontal x transformations. So if you want to go in the negative direction by 2, you're actually going to add 2, which seems wrong, but what's happening is really that x has to decrease by 2 in order to make up for this plus 2 being added. And again, you can figure this out by plugging in points. So take this formula, make sure it's the right formula by plugging in -2, and make sure you get 2 for your y value. Okay, so plug in -2 right here, then you're going to get 0 for this part. Then it's just going to be 2 over 1. Yeah, that's what you want. All right, let's look at the last one. So here's our formula, and again, you could just totally just plug x values into this formula, see what you get. But I think I can already see just from looking at it, the difference from the original formula is this negative that got put on the 2 right here. So this negative on the 2 could also be written over here like this. So somebody has taken our original formula. It was me, I did it. I confess. Somebody, a horrible, evil math teacher, which was me, took this formula and put a negative on it, which means they did the transformation to the outside of the formula, so it's a vertical change, and making it negative is reflection. Okay, so this is vertical reflection. And vertical reflection means you switch top and bottom across the x-axis. All right, so then for this sketch, you're going to take each of these points and you're just going to flip them to the bottom across the x-axis like this, and the whole graph is going to go down here, just connecting in the same shape as best as you can as before. And there it is. All right, that's it for that problem. And I think there's one more. Okay. So our original function is f of x equals x squared times x minus 2. Now this is a little bit different because there's 2 x's in this formula. So any horizontal changes that we need to make, we're going to be doing it to both of these x's. All right. So let's look at the first one. Okay, so I see our reference points here. What has happened to them? So the black point that was here got moved over here, and this point stayed in the same place, and then this black point got moved over here. So I think this is a horizontal reflection, or in other words, left to right reflection, reflection over the y-axis. So left to right y-axis. All right, so what is the formula for horizontal reflection? Let me copy our original formula here. So this is going to be, what change do we need to make? So first of all, it's horizontal, so the change needs to be made to x and to both of the x's. And since it's reflection, we're going to make those x's negative. Now you got to be careful to go in parentheses and do it directly to x before any operation has been applied to x. So like, for example, with this one, it's not going to do anything, right? It's just going to become x squared again because it's squaring makes it positive again. This one, we could simplify it and just take away the parentheses since we already had, it's not going to change the order of operations. Or you could just leave it like this. This is fine too. All right, let's look at the next one. Vertical shrink by a factor of 1/3. So let's sketch it first. So for sketching it, we're going to take the y values and we're going to make them 1/3 of what they were. So this y value here is 0. 1/3 of 0 is 0. So it's going to stay there. This y value is 0. 1/3 of 0 is 0. Stays there. This y value is -3. 1/3 of that is going to be -1. Right? So this one's going to go to here. Oh, Microsoft is trying to interpret what I want again, but I wish that it wouldn't do that. Okay, and then we could do like this one right here, even though we weren't given a point there, but make it 1/3, so like right there. And then just try to connect as best as you can to kind of the way it was before. It's like this point here was at 3, so it's to come down to here. This kind of thing. It's kind of crude, but like that. Okay, and then so for the formula, so here's our original formula, and we're calling this g of x. Okay, so it's a vertical change, so the change is going to be done to the outside of the formula. It's shrinking, so that's going to be multiplying by a number, and then it's a vertical change, so we just do it the way that makes sense, which is multiply by 1/3. Again, plug in a point to make sure it works if you're not sure. Maybe plug in one of the points that actually changed, like -1. So if I plug in -1 here, I get 1. Plug in -1 here, I get -3. And then -3 times 1/3 is -1. So that gives me back this point right here. Okay, last one, we're given the formula. So what has happened to our original formula? So it looks like the first x got 1 added to it, and the second x also got 1 added to it. So we added a number to x's. That means it's a horizontal shift. And the only question is it left or right by 1, left by 1 or right by 1? So you would think +1 should go to the right because it's positive, but all the x transformations are backwards, so this is left by 1. And if you're not sure, again, you can just plug in points. Just plug in points, okay? So like when I plug in 0, what do I get? Let's try plug in 0 right here. 0 plus 1 squared, so that part's going to be 1. And then 0 plus 1 minus 2, so this is going to be -1. So 1 times -1. So when I plug in 0, I'm getting -1. Okay, so this is right here. And that's actually because this point right here moved over. So you can just keep plugging in points like that. Plug in -1, plug in -2, or you can use the fact that this is, the formula tells us that it's horizontal shift left by 1. So that point's going to move there, that point's going to move there. This reference point that wasn't like explicitly given has moved here, just like we calculated. This one's going to move here. Okay, so this is going to be like kind of, yeah, like this. All right, and that is it for this type of problem.